So we're continuing with solving linear systems of three equations and three variables. We learned that the system can have it can be either inconsistent system with no solutions, or it can have infinite solutions, or it can have a unique solution. Unique solution, we gave an example when we discussed the row reduction method. Infinite solutions, we gave an example. And it's appropriate at this point to give an inconsistent system example. So again, we use the row reduction method to arrive in the what we call reduced row in what we call row echelon form. So going about with this and finding the row echelon form, we start with leading one. In this case, leading one has been created. The next thing to do, leading one in the first row has been created already for us. The next thing that we need to do is to use the leading one in the first row to eliminate the same variable in the following rows. So to do that for this row, for row 2, I have to use row 1. And add negative 2 times row 1 to eliminate x in row 2. So row 2 is 2x minus y minus 2z equal to 10. Add negative 2 times row 1 and we arrive at negative 11y minus 10z equal to 0. Now, replacing row 2 with that and not changing row 1 and row 3, what we this system. Row 2 and row 3 unchanged. The next thing that we need to do is to use the row with leading 1 to eliminate the same variable in the last row. That is row 3 plus negative 3 row 1 should go to row 3. That is 3x plus 4y plus 2z and negative 3x minus 15y minus 12z equal to negative 15. This will give negative 11y minus 10z equal to negative 5. Replacing the first row does not change. The only row that's changing is row 3. Again, I can see that I can eliminate y in the third row easily. even more, I can see that and I can multiply the second row by -1 and add and completely eliminate both y and z on this side of row 3. But there are merits in following the same rules and the same methods of bookkeeping when the systems get very big. So I continue with the same methods that I have. That is creating, now that I know that I had a leading one and all variables, that variable was eliminated underneath. Now I need to create another leading one for the next variable I can, which is y, and I just do that. And so what I do is I multiply row 2 by -1 over 11, and I replace row 2 by that. So x plus and y plus 10, 11z equal to 0. And -11. -11y minus 10z equal to -5. Now we use the row with the leading one for y to eliminate y underneath. And so that would be row 3 plus 11. Row 2 goes to row 3. And I don't need to use a scratch paper. What I see is, let's just use the scratch paper though. Row 3 is -11y minus 10z equal to -5. Row 2 times 11 is 11y plus 10z equal to 0. So it will give me 0 equal to -5, which was what we were actually expecting, because I could see that the one side of the two equations were the same and the other side was not. So replacing this into the system, what we get is this system: x plus 5y plus 4z equal to 5, y plus 10 over 11z equal to 0, and 0 equal to -5. At this point, I look at my equation. The very last equation is a contradictory statement. 0 is never equal to -5. So this is a contradiction. Therefore, the system cannot have a solution. This is an inconsistent system.